What's up, people? It's a new day. Okay, so yesterday, Sephiroth's loud, man. Yesterday, we debugged the server refactor hard exit hang issue. Um, then we also implemented and tested child process termination procedure, and we need to review all added code in server refactor. Gotta put this incense out. It smells wonderful. I can like feel it giving me an instant headache. Sense. I usually just like burn candles or oil. They're really cheap on Temu. I was like, let me get some incense, but they create so much smoke, and they kind of give me a headache. So anyway, back to it. All right, so we need to set our timer here. Let's go ahead and do that. My leg is still busted. I had problems with it. This was like a year or two ago. I remember actually I had to go to the hospital. It got so bad. It was just like it's just like a twisting. It's like you twist it, and it's bad. It's like sprained. Describe it. Okay, so we started debugged. Need to review the code that we added yesterday because we didn't really do a thorough review of it. We added a good bit. I was testing it. Right here, a little no need to grow code reset refactor. So let's go ahead and do that. Let's go review yesterday's code to server refactor. Okay, so let's go see if we have any extensions. Yeah, Control Shift X. Start. There we go. So let's see here. We got where did we start the refactor? Uh-oh. Power showing yellow. I've never seen it show yellow before. Following extensions want to relaunch the terminal to contribute to its environment. I mean, that's fine. I don't care if it does that, but it looks like it's not going to do that on its own. Apparently. I've never seen it show yellow. Looks like it's not going to do that on its own. There we go. Baby. There we go, baby. Alright, so let's start. Alright, so we determined, I guess, that this is where we started, by the way. Right here, about this try block. And I don't think we actually need to use signal. I don't think it was actually the problem that the child processes were staying alive. It was actually the accept method that was blocking the main process. It wasn't actually the child processes. So I think the child processes are actually properly closing. They're doing what they're supposed to do, I think. So let's test that real quick. Let's pop up the server. refactor. Okay, so apparently it's from S. Then we're going to do client refactor multiprocessing. Same thing over here. Now we have the two clients connected. And if we don't ever download Driver Booster, just a tip. Okay, there we go. So yeah, the child process did indeed terminate because, well, let's verify this. We're going to go to the task manager, and at this point there should be no Python running, and indeed there are no Python running. Let's do it again, and you can see the Python scripts appear. Here they are. It's like complicated. And there's really just there's the server and then there's the two clients. Actually, you know, I kind of want to know just to see. And then when we kill it, you can see they're all gone. So let's run the server again, and let's see what shows up now. So the server's running. So now you have this Python, and then you have a second Python. I don't really know how this works exactly, but you have like two processes for the one server script, and then you run client, and now you have this second 32-bit. After you run this one, the second client, now you have the third 32-bit. So this first one Python and then this Python are from the server script, and then these two 32-bit are from the client script. And then this second Python process is the game process. I think it is, unless it like moved down or moved up when this might be the other one. So you can see we killed that Python process, but these clients are still running. But the server itself is down. And then if we crank the server back up, we have two Pythons again, even though we killed one of them. So yeah, you can see there definitely is the multiprocessing going on. There's two processes, and it is successfully killing them when we attempt to do so, which is good. So it turns out we don't actually need signal. And why have extra code? I don't like extra code, so we're going to get rid of it. So we don't need signal. And we also don't need that Boolean we created. I guess we deleted it already. Yeah, I think we did. We deleted it already. It's already gone. Okay, so let's start at the top here. We got try, processes list, processes dictionary. We don't need this actually anymore because we're not going to use signal handler. So we can actually get rid of this processes list and the process list append. We have a processes dict, process ID, multiprocessing pre-support, this is equal to socket, and this all works. So we'll put a double stamp approval on this. So far, everything here is working as it should. Our process ID, that's used, like you can actually get the, and I'll put a little note here. consider using the os.pid instead. Maybe, like, it's, we'll think about that, and when we'll cross that bridge when we get to it, because like technically we already just get the process ID using ospid, but I don't know. We're actually gonna end up using use the restroom. Back. FQD calls? You answer. Alright, so we did not get very far here. So we have server bind, listen. So all this is good, I think. Just read multiprocessing. Pre-support is essential for multiprocessing on Windows to correctly without causing it to freeze. All process execution must be executed in this context. Yep, that's good. That's good. Port equals 49, 152. Recommended they are in dynamic private range and are usually free, so we use that. Then we have this comment here. Comment added 3/2024. Get FQDN, get your local machine domain, and then get host by name. Translate that domain into an IPv4 address. This way we don't have to manually update the IP address here every time the IP address is changed for whatever reason, as long as the host address. Need to create final version of this code. Reflect the fact that the game is remotely hosted, or however that will be done in its final state. Okay, then server is equal to socket get host. Well, that's what we just read. The comment for server socket get host by name, socket get FQDN. We know what FQDN stands for. Server bind, then we bind to the server import, which is necessary. Then we listen, allowing 100 to be queued up. It's the arg is a backlog. Can even be a little bit more specific here, and we'll just say connection backlog, say attempted connection backlog. Function as a queue to hold pending connection request. 100% is good by verify doesn't need to be inside of while true. AKA only needs to be run. Run 1x. That's good. Client 1 connected is equal to false, and then client 2 connected is equal to false. And what is this used for? This is used to determine correct client connection logic immediately. Yep. Alright, then we have below line. This has to be run in a while loop. If it is not, it will not connect the second client. This one should not be. This is the old comment, isn't it? This has to be run in a while loop. If it is not, it will not connect the second client. Accepts two connections and no longer runs. As this, well, that's not an accurate comment anymore. We've changed that. While true runs until we hard kill the script. And what does it do? It connects the two clients for a game and begins the game process. Begins the new game process. Runs into it hard to kill the script. Then we have ready equals select, and we're using S as the readable selector. Nothing for the right, nothing for exceptional, and then 0 for timeout. Timeout must be 0 for this to work. Okay. Now we have if client 1 connected is equal to false. So if the first client has not yet been connected, then we would say if ready at 0 to check if ready, if S has anything that is ready to be received, that being an attempted connection from the internet. And if they have something there, if it's not empty, or not equal to whatever that implies. I don't know if it's the same thing. Maybe it's either or. It's like an empty list or a value, but I think they both return false rather, which it's like that would be false if there was nothing there, or if it was equal to none. If there was something there, or if it wasn't equal to none, it would be true. So then it would enter into this if as true, and we do client one socket equals s except. This is a blocking this method is a blocking method. We'll just say blocks until client is connected. Returns socket object. Yeah, like we don't really need that highlighted anymore. So it consists of tuple, con adder, right? Okay. And accepts only one client. That's fine. Okay, that's good. So let's say client one connected is equal to true at this point. So now client one is connected because they are connected because, well, accept has been run and there was something in the selector to be read, which had to be that connection. So we changed this bool to true. And then, well, I was thinking we have live here, but I think it would actually be better to use if, because let's say, well, let's say they're both ready, right? Let's say they're both ready. Like they're both. I guess this socket, server socket, might have. Might have two. I was thinking this. Should I have two sockets? I don't think I ever did. Like one for each client. I don't think that's how you do it. I think you just use the socket. Now that's something to consider here. Should I use two different sockets? Well, no, because then there'd be no way for the client to know to use. You know what I mean? So yeah, we just use one. I'm pretty sure. Yeah, that's the way to go because the client has knowledge. It has to be like a static changing thing for them to like have it on the client side, unless they access some like registry. I know they use a registry, but it's fine. We'll just keep it this way with just one. So we have client one socket. We already went through that. So this should probably be changed to if client two connected is equal to false, because in this while loop, let's say client one ends up getting connected, but ready is still ready. They still have client two's connection waiting in the queue to be accepted. In that case, we would want the if, because if it was elif, it wouldn't run this. But if it's if, it would run it, and therefore it would connect that client. So if client 2 connected is equal to false, and we want to keep it this way, we'll say keep this if not elif, since both clients might be attempting to connect, or elif would skip the second in this case. True. So now we say if ready 0, if S has anything ready to be read, same thing as before. We did same exact thing. Client to socket. I was gonna say we could turn this into a function. That would literally only save us like 1, 2, 3, 4. That would save us like 3 lines. It's not even worth it. So if we're ready 0, then we accept. Return a socket object. Let's change this to reflect this new comment, the new and improved version. Client connected to client 2 connected is equal to true. And now we check to see if client 1 connected is equal to true and client 2 connected is equal to true. So if both clients have been connected, then since above 2 lines are blocking, should not proceed to both clients. Yeah, we already need that before. In this case, we would then start the new process, passing the individual game as the target function, and the 2 args we would pass would be the 2 connections, aka the 2 client sockets, so client 1 socket and client 2 socket. And yeah, it must be executed, otherwise we'll recurse to a certain process process forks. Yeah, I mean that's fine, we can leave that comment there, just in case I forget about that. Then we have process get started, process dict at process ID equals P. Okay, so we register that into our dictionary at that process ID, then we increment the ID. So it would be 1, and then it would increment to 2, and then it would, the next one would be 2, then it would increment to 3, so on and so forth. Then we reset both of these back to false for next time. Well, we could, but we don't want to do that because then setting them back to false every while iteration. In the case that ready wasn't ready, just be resetting these back to false over and over. And actually that would be bad logic, because then even after client 1 got connected, it would reset this back to false, which would result, that would actually ruin the functionality of the game. It wouldn't work correctly. Keep outside of below while loop. Yeah, okay. There we go. And so this is resetting these back, resets back to false, to for next time while loop is run. For next set of clients. Yeah. We have accept necessary to trigger logs for killing script in case of exceptions. Necessary to trigger logs for killing script in case of exceptions. Yeah. Then we have traceback print log function, add process ID to server log, so we do want to do that. I mean, do we really need that? Well, I guess it'd be good to have. So the way that we could do this is, well, we could simply pass the process ID as an argument to the individual game, and then just use that in all of our logs. So that's one way to do that. Okay, and then we have if so log in the custom log on off switch is equal to true. This kills the main process. Get frame f-line and server by script. Prints out all the logs. Yeah, and all this is correct for item in custom logger log list. And then we print the item. Yeah, that should all be correct. Okay. Now, what are we doing here? Okay, so now I think we're gonna add the process ID to logs. So we're gonna add process number, aka process ID to server logs. So this is gonna be pretty easy, but let's go to devlog and put that we finished the task of reviewing. So we did this. Review, just use code out of server refactor. Everything looked great. Yes, and now we're going to add in logic for process ID to be included in logs. In server refactor. So let's go over here. And what we'll do is we're going to pass the process ID as an argument. So now we need to go up to the top here and we're going to take another process ID argument. So now we need to go through and find, trace back, and what we're going to do is we're going to add in the well, I think we probably need to when it gets past I think we can just directly reference it. Since it gets passed as an argument, I don't think we have to then say like process inside of the function, say process ID equals process ID to reference process ID. I think we can just straight up reference process ID after it's passed in as an arg. Like, yeah, duh, yeah. So we'll say PID number and then or would you say PID and then put process ID. There we go. So we're going to add this little snippet of code, PID process ID, to each of these. And I think I just realized something. I think we would need to um, I think we'll need to make the process ID be equal to zero, or like we need to change how process ID is set. Um, because currently, well, we should actually have the process ID first for these. So let me go back here, fix them. Yeah, so we'll put the process ID first. Because currently, both the main process and the child process would have a process ID of 1. They'd have the same process ID. So the process ID needs to be incremented actually before the process is started, so that when we start the process, we can pass the already incremented process ID. Does that make sense? So we're not going to have a duplicate process ID for the first child process, as that it would match the parent process ID, which is not good. So we're just adding all these. Going through here. Okay, there we go. We did it. That was easy. Now we just need to go down here when the process ID starts, and we're going to make it, we're going to increment it first. We'll say must increment first so that main process doesn't have same process ID as child. Yeah. Yeah, process ID plus equals 1, and then, so at this point it would be equal to 2, and then the process ID would be 2, so the main process ID would be 1, and the first child process ID would be 2. Make sense? Easy. Okay, so we're done with that. That was easy, baby, easy. All right, moving on to the next one. Take a sip of some water here. Okay, what's next, baby? What do we need to do? What's down? Let's see. Okay. Next would be, well, let's go ahead and test it. Let's make sure it works. Okay, so we're testing the process ID, and you can see that the 876 would be a part of the child process. So we know it's working. PID 2, it should be 2. And everything's working as it should. Okay, let's exit that and see if we get process ID 1. Okay, I have this as a print. Okay, so I do need to add it here. I didn't add it. But it should still have had... Oh, okay, I see now. This is actually bad logic. I have to assign... Yeah, I'm dumb. Okay, that's stupid. I'm an idiot. Um, Process ID, it has to be, you basically just have to have two separate variables. Like, that was dumb. That was dumb of me. Um, okay, so let's see about this. We're gonna go up here. And have process ID. Well, I know what we can do. Let's use, we have process ID, and then we're gonna have main process ID. So this is always going to be one. Okay, so we change this. So now this is going to be, it's set to 2 initially. Okay. And the main process ID is set to 1. It is used in the main process. There's only a couple places, so I just added it. And then we have child process ID is set to 2. Okay, so since child process is set to 2, then what? Well, then we pass it to the process, the new process when it's created, and then we increment the child process ID by plus equals 1. We need to have that after that. So, okay, so let's make sure we got this right. We have the main process ID set to 1. That's used only in a couple places. It's used right here and then at the very end of the file right there because it's in the main process. Now, everything else is going to be associated with the child process. So we create the child process ID set to 2 by default. when we create a new process, we pass that child process ID, so it's going to start at 2. So it won't be 1 because 1 is for the main process. So we don't want to have the main process, the child process, have the same ID. That's why it starts at 2. Then we start the process. We pass that child process ID to the process dictionary, and then we increment it. So this has to be right here because we need this child process ID to match the actual, it has to match the actual process ID. We don't want to increment it first and then add it to the dictionary. Otherwise, we would be grabbing the next child process in line, which would just be wrong. So, and then we increment the child process ID by 1. So the next time it will be 3. Then pass 3, and then register to the process dict at key 3, and commit it to 4. So on and so forth. So now this should be perfected. Should be. Let's see. Let's test it. And so we have process ID 2 for 876, so that should be correct. All this should be 2. I think that's correct as well. We should see process ID 1. There we go. So it is showing process ID 1. Let's go to the top so we get our context. Right, so everything is showing process ID 2 until the point at which we hard kill the script, and that's when we get PID 1. So on and so forth. We get PID 1 here as well. And why is we want the line number to be first? So this is line number 941. That's one thing I do want to be first, is the line number. Because that helps me to know where, what line we're dealing with. There we go. So that got changed, and here we go. Okay, everything's working. Alright, so we tested it, we fixed that. Let's go back over here. So we actually ended up going to 208 for that. Let's correct our time here. Okay, so what is next here? Okay, well, I suppose now that we got that figured out, where we can kill the server script on command easily without having to like click and all this stuff, we can, let's get rid of these terminals because I guess it wanted me to reset them. So there, now it looks good. So now let's test and see why it's not working. So like, it works, but it doesn't actually work as it's supposed to. It doesn't start the game correctly. Like, it's showing that it's waiting for the other player to join the server. So let's figure this out, because I thought we had it working. Well, we did. I remember, yeah, we did have it working. The only thing was we didn't we didn't have it show when the first client goes to connect that like their screen, their window didn't pop up like this. But it worked. Once the second client connected, the game was running as it should run. But as you can see here, we do have the window pop up immediately whenever they start their client, which is cool, but it doesn't run once the second client connects. And I suspect that this has to do with the, let's see, I suspect it has to do with the fact that we added in this preliminary code. Where is it? Is it in the main while loop? No, it's before the main while loop. It's way up here. Okay, here we go. Right here. Let's see. This preliminary setting of the Pygame mode. So let's go ahead and disable this. Well, I don't think we can just disable it like that because, yeah, we had it. Well, let's just move it back to how it was. Well, no, we still have it here. We have waiting other player, waiting for other player to join the server, but we did move the set Pygame video mode, didn't we? So this would have to be moved. Let me just reference the other client to see how we had this previously. Okay, so let's disable this. So now it should be as it was. So let's see if it'll work now. Client ID is not defined as unique client. Processing. 345 right here is equal to, okay, so client ID does need to be set to none. There we go. Okay. There we go. And it's working. So now you have your two clients. And now if we start some new clients, we have a new set of terminals. Well, we don't need 3 actually. There we go. So now we have another game instance, second, and then this would be game instance. So we have 2 game instances going on here. So this is, uh-oh. There it goes. Yeah, a little bit of lag there for whatever reason, but you can see it works, which is pretty cool. There you go. And so we got 2 game instances running, and then we can just do this again, and we'll have a third. There you go. Now you got 3 game instances running, and third game instance. Yeah, baby. So that's 3. So now we have 3 games going on right now. 3 instances all concurrently running. Pretty cool. Yeah, good stuff. So I'm gonna go ahead and take a break because time is up, and I gotta fix this now so that we can get. Just kill all these. Reverted client refactor multiprocessing pi back to working state. Reverted client refactor multiprocessing pi back to working state. Back to working state, and then we'll just put need to make it so that disabled code is modified to allow for initial client 1 display, but with the rest of the game working. Currently, if enabled, it will allow for initial client 1 display, but it doesn't allow the it doesn't allow the rest of the game to play. All right, so I'll be back, take a little break, and yeah, so see you in a bit.